Alex Pault, editor-at-large for Electronic Design, and I'd like to welcome you to another Tech Exchange talk of ours, where we talk to interesting people in the tech space about some of the interesting things that they're doing. Today, we've got Keshav Amla. He is the founder and CEO of Avishtech. Welcome to the show, Keshav. Can you tell me a little bit about that interesting company name of yours?
Sure. Thanks, Alex. So the company name it basically comes from a Sanskrit word Avishtech, which means invention, and then tech is of course tech.
Well, I mean, engineering is essentially applied science, right?
Right.
And the goal is to invent those solutions, and that job's getting harder every day, isn't it?
Absolutely. I mean, because and part of it is that people kind of I caution against the other extreme in the thought, though, of course, that there are a lot of people who think everything that's going to be invented has already been invented, but if as history has shown us, people are always thinking that, and it's never true. So
Yeah, and computers will only need 640 K of or gigs, whatever. Draw the line. I think it was Gates said
yeah,
K, but
yeah.
it's always a moving target.
Mhm.
The core technologies develop new methodologies that create new solutions, which prompt the discovery of new core technologies.
Exactly. So it's all a cycle that moves things forward.
So now, speaking of a cycle, we're currently in an interconnected smart ecosystem that we're literally building as we go along.
Mhm.
That's a lot of challenges to the designer, isn't it?
For sure, for sure. I mean, designs are getting more complex, and there's so many different things that one has to keep track of and make sure you're delivering on all fronts. So it's there's a lot that has to be considered for the design process.
Now, there's been a lot of growth and expansion and development in design software, collaborative design software, interpretive software tied into the supply chain. The tools are really getting complex and functional.
Yes, for sure. I mean, basically, whatever the designers and engineers are needing to pay attention to, they need some kind of a solution that's addressing those. And so I think that's been for us, that's been a key driver of what we set out to develop and what we've been developing ever since we launched.
Well, and that takes us exactly to where I'd like us to be, is talking about where you're injecting your value add into this entire situation.
We're going to start here with so this is a bit of a fairly complex diagram, but it touches on what we're talking about in terms of the whole process and where what we're really addressing. So in the typical electronic design and validation process, this is kind of where things start. You start with whatever you're developing. You figure out, well, what are the specifications going to be? What is this product going to do? What kind of capabilities will it have? And once you generate that list, then you start figuring out, well, okay, let me put together schematics. Let me figure out what components I'm going to need. And that's when once all of that's done, then there's IC level simulation that's done on the silicon, the chips, and once everything checks out, once that tape out is complete, that's when things start to move from the chip side to the printed circuit board side. And so this is when PCB layout is typically done. Then it moves to what we see as the most critical step, but one that has been largely ignored in terms of the industry writ large, in terms of software that can support this, is the Stackup side. So this is when you start putting together a printed circuit board Stackup. In the traditional process, there's some piecemeal simulation. So you look at some aspects of your signal integrity and maybe power integrity. But then then you basically select your materials and you build prototypes, and that's a serious pain point, because that's really expensive, cost lots of time, and delays your entire product launch. And inevitably, when the prototyping doesn't work, you have to reiterate and respin, which is costly, which is very costly. And then the issue is that how do you figure out, well, what materials should you use? And so every OEM basically has their own process for materials qualifications. So that's also a very expensive process. Can take years, and basically it's to figure out, well, okay, well, is this material going to qualify or not? Is this something we can use? And so they'll have a test vehicle for the signal integrity. They'll have a test vehicle for reliability and thermal behavior. And the problem is that even with that, even with prototyping, you still can't prevent field failures or manufacturing failures. And so these were the two major pain points that we really saw in this whole process that nothing was really addressing. That's where these qualifications can take years. They're very expensive, and they don't really work because a test vehicle, it's a one shoe fits all approach, and every design is different. And then even within the designs, prototyping. The thing is, I mean, unless you build a very large number of prototypes, you still aren't going to capture, the full statistical range of what could happen. And so even with prototyping, you could still run into these kinds of failures. And so we set out to create a simulation and design environment where you can predict all of these failure modes right at the design stage. You can eliminate the need for prototyping, get rid of the respins, and basically enable users to get the optimal design the first time and go to market faster with better and more reliable products. So and overall less cost in this whole process. And so this fairly complex procedure, we said, let's eliminate the prototyping, let's eliminate the respins, let's eliminate the qualifications, and if we do our job right, we'll also eliminate manufacturing and field failures. And so this is basically what we're doing, is creating this more streamlined process to where the tape out that the IC side, the semiconductor side, we're not operating on that side. That stays as is. But then once you go to the PCB side, things stop looking so haphazard, and things stop being so painful in terms of getting a product out to market. And so here, basically, you do simulations that with Gauss that allow you to look at all of these different aspects and design problems out of your product before ever having to build anything. And so you can iterate and optimize in days where the process used to take months, years, maybe never sometimes, right? And so that's basically what Gauss has been doing, what we've been doing with Gauss. And so to kind of show, well, what does that really mean in terms of what is a user doing with our software? And so basically what happens is that we've made this also very easy for the users by going out, so we built a full library of all the relevant materials. We've extracted all of the relevant polymer level properties, and then we use our compute engine, which is at the core of what Gauss Stack does, and that basically runs these simulations that allow you to take all of these constituents which are in our library and figure out for these woven composites at the board level and at the layer level, what are the thermomechanical properties. And so it figures all of those out, and highly accurate. And with those properties, then you can figure out, well, okay, it can predict issues like glass stop and resin starvation, which can lead to early calf failures and high pot failures. It can figure out, is my board going to warp? Is it going to survive assembly? Is what about my solder joints? Are they going to survive service life? Same for your plated through holes and your microvias. You can look at how they're going to fare in reflow, service conditions, testing, and with all of that, and then on the signal integrity side as well, you've got. So we've accounted for ground plane losses, which were a major missing piece from the insertion loss simulation side of things, about 30 to 35% of the loss. And so now you can actually you can take the simulation results and actually have them be meaningful without having to hunt for data or use fudge factors or anything like that. And that's basically what we've been doing with our software. And we're every little bit we're coming out with a new capability. And so with Gauss Stack Pro, which we recently announced at DAC, that was now we're also accounting for the layout in a lot of these capabilities, and we're constantly adapting our solutions for more and more so that you can get all of the visibility that you'd care to have, and that's how we're helping with this ever increasingly complex process to make it simple and workable.
Well, Keshav, it is all of a gestalt, right? And the more you can perceive of that gestalt, the better you can design. When you think about issues like board parasitics and materials issues and the vias, it can easily get away from you. Have a tool. I mean, I'm impressed. I come from the old analog days,
Thanks, Alex. Yeah, no, it's you're 100% right that one of the biggest reasons why, both on the side of designers and engineers, this side has been so challenging, and also in terms of the software solutions not being available. It comes down to the fact that all of this is highly multidisciplinary. I mean, you're having to pull from mechanical engineering, from material science, from electrical engineering, all sorts of different disciplines have to factor in. And if you're a PCB designer or engineer, you won't necessarily have focused on some of these other aspects. But they matter to you just as much, because if the last thing that you want as a PCB developer is if your board's not surviving, right? I mean, then whatever performance and things that you were concerned about become secondary, because if the board can't be manufactured, or it can't be assembled, or it fails early, that's all moot. And so all of these things matter to you, but first of all, in the absence of software that can allow you to look at this, you historically just had to turn to build it and test it, and even that process, even with how expensive and time consuming and labor intensive it is, still doesn't get you where you need to be. And so here, when you have that ability, that instead, you can't make 50 different revs, right? But you can make 50 revs on your computer and with Gauss without any hassle or issue. And that's where the challenge, the disconnect has been, and that's the gap we've been seeking to bridge.
Very cool, Keshav. So what would be the process then? I walk into your front door, hat in hand, and say, I want to tighten up my board. What's the next step?
Well, so yeah, in fact, that's usually how the process starts. That somebody comes to us, they say, we've been facing XYZ issue, and we don't know how to fix it. But I've heard about your software, and it sounds like maybe it could help me. And so then that's kind of how the process starts, and then we'll usually what'll happen is it takes a few different paths from there, but usually the path will be either either after the initial intro demo that we give them, usually it'll move toward, well, okay, it sound based on what you've shown me, it does sound like we're in the right place. So these are the issues that we've been facing. Could you tell us if your software would have predicted this issue? And so oftentimes it'll be completely blind. They'll just say, here's my Stackup, here are the conditions that I want you to simulate, and tell me what the results are. And then usually what will happen after that is they'll say, okay, well, so it sounds like it would have predicted the problems that I was facing. So then it just kind of moves from there. And once they have it in-house, then and this is what we've been seeing, is that they start to it changes the way that their design process works. So not only are they relying on it to catch these issues, but they're able to move a lot faster than they used to. They're able to come up with and they're trying things that they never were before, because and so that's where sometimes if someone's really trying to push the envelope, it's enablement, not just helping you save costs and time, but it actually enables you to do the stuff that you were trying to do, but didn't have a path forward for.
Working towards true system optimization. It really is a necessary thing, especially now with all of the stuff going on. And a global view is critical. It's critical nowadays, especially since you've got software controlling half this stuff now. You have to have a complete awareness of every aspect of the circuit.
Exactly. I mean, there's a lot that you have to keep track of, and what we see is that everyone will take whatever help they can get in doing that, right?
So, do you have any final thoughts before we let you go, my friend? It has been a really informative conversation, but I'll let you have the last word.
I mean, yeah, it's been a great conversation. Nothing really more to add. Just appreciate the time.
The pleasure's mine, Keshav. I really, really appreciate your time. And I'd like to thank everybody out there in the audience for taking the time to be with us. We appreciate that too.